Hi, my name is Mark. I'm here to help you with your GCSE and A-level math studies. This week's topic is called the discriminant. The purpose of today's video is what we're going to do is look at some practice exam style questions. This week's topic is usually aimed at right at the very start of the Year 12 course. For those sitting the pure stats and mechanics papers, it will be on the pure papers in the algebra and functions section. For those that are just finishing GCSEs, it will be useful to learn about the discriminant now so that you can get a head start on the entire course. As always, I will show you how to attempt these questions in a bit more detail. But feel free to ask me any questions in my office hours live streams from my website in the members area. So let's get started on today's video. This is a practice exam question. And it's talking about kx squared plus 4kx plus 3. First things first, what we should do is see if we are finding the solutions to a simultaneous equation or the equation itself. Here we are given one equation and we are told it has no real roots. From our knowledge of the discriminant is b squared minus 4ac. You'd have seen that before in the quadratic formula underneath the square root sign. If it's negative, you can't square root a negative number, so you get no real solutions. If the discriminant is 0, square root is 0, there's no point adding and taking away 0 because it wouldn't make a difference. So you'd only get one repeated solution, it's called, a solution that counts twice. If the discriminant is positive, which is the majority of times in GCSE, if not all the times, you get two distinct solutions. Because this specifies the equation has no real roots, we know the discriminant is less than 0. So, deciding what is A, B and C, do we have to make it equal to 0? No, the quadratic is already equal to 0 in this case. So what we do here is look, A is the coefficient of x squared, B is the coefficient of x, and C is the coefficient of the constant term. A is equal to k here, B is equal to 4k, remember the sign as well, it's a positive 4k, and C is positive 3. So, the next thing we do is sub these values into the discriminant. B is 4k, so 4k, remember to put brackets around it because it's all being squared, minus 4 lots of, A is k, and C is 3. We are told that it has no real roots to this equation, so the discriminant is less than 0. Squaring out the 4k bracket, we get 4k times 4k is 16k squared, minus 12k, and that needs to be less than 0. On this particular example, we have got a quadratic in terms of k now, so be careful when you're solving quadratic inequalities from GCSE, the higher end level 8 and level 9 GCSE, you need to remember to draw your quadratic graph. So first of all, imagine 16k squared minus 12k equals 0. I know it doesn't, but just imagine, so you're finding the solutions to where it equals 0. You can take a 4k out. This is a bit nicer because it doesn't have a constant term, so you don't have to use the quadratic formula or factorisation to solve it. And then 4k minus 3. Don't forget about the 4k bracket. You have 4k has to equal 0 or 4k minus 3 equals 0. You get two values for k. K equals 0 and k equals 3/4. That is where they get the 0 and 3/4 from, but just be aware that we have to go a step further. Because going back to 16k squared minus 12k being less than 0, draw a quadratic graph, but not on the x-axis. We have to put the value of k because this is a quadratic in terms of k, not the original x. So we've got a quadratic here, and we've found where it hits the 0 line, in other words hits the k-axis. That is when k equals 0 and when k is 3/4. We are asked for where the quadratic is less than 0, the quadratic in terms of k. So on the k-axis, where the quadratic curve is below 0. So it's below 0. When we're talking about below 0, we're not talking about the value of k on the k-axis, we're talking about the result, so the y-coordinate. Where is that below 0? Well, it's where the curve dips below the k-axis. So it's this part of the curve. Each values of k you can sub in so that the quadratic results in a negative number. So if we're talking about that part of the curve, which values of k gives a value out that's below 0? And it's these values of k on the k-axis. So you do not split the set up into two distinct sets. It's just one continuous set between 0 and 3/4. So you'd have to write your answer as one line, not two separate ones. Okay. How you'd write that is put k is in between 0 and 3/4, which would usually be fine, but just be aware to check the end bounds if it still satisfies the original equation. Not for the case that it would make the discriminant less than 0, but for other reasons, such as if you subbed k in as 0, it will eliminate part of the quadratic. So I would always say double check. If you subbed in, let's say k equals 3/4 into this, the quadratic would be 3/4 x squared plus 12, 4 times 3/4, no, mental arithmetic. 4 times 3/4 is indeed 3. Okay, so you'd have 3x plus 3. And just checking your calculator, would that have two real solutions? Well, what we would do is, you can check the discriminant if you want and see, or you could find the solutions in your calculator quickly using the degree polynomial method. And you have -2 as a solution. So you would get a solution, okay, and it's specifically asked for no real solution. So what you need here, okay, this gives one solution, so this won't work, okay. So that case will not work because it will give one solution, not no real solutions. The other value you can check is, let's check k equals 0 and substitute it into the quadratic. This would, in this case, eliminate the x squared term, and you're left with just, and the, if you sub it into the 4k, you leave it with just 0 x's as well. So you're left with 3 equals 0, which does indeed have no solutions. And that does satisfy the property that it has no real roots, no real solutions, okay? So actually you do, in this case, need to include k equals 0, which is why it's important to check the bounds, okay, and why it specifies k has to be above or equal to 0. So what I would do is, okay, put and k equals 0. So to write that as one answer, you'd put 0, or k is above or equal to 0, so it includes it, and less than 3/4. And that would be the solution to that question. We have proved it, which is another way of showing that, but in a bit more detail. Right, so the second exam question that we're going to have a look at today is off a previous Edexcel past exam paper. It's from the June 2024 paper. It was off paper 1 for the year 13 students, and this was about halfway through the paper, question 8. It does involve a bit of functions to start off with, that GCSE students will be able to attempt the majority of, apart from the domain and range, which students do again in a bit more detail in year 13 in the second year of A-levels. And the discriminant part comes in part D. So just as a bit of an added bonus, what I'm going to do is work through this question, but always give it an attempt first before you hear what I have to say. Right, so let's have a look here. Okay, we're going to find fg of 2. This is a substitution method. But remember, when you are doing composition of functions, might be a while ago for GCSE students are doing this, but okay, you always have to apply the right hand side function first. So it's g first. Essentially what you're doing is you're doing f of g of 2, not f of 2. So what you need to do is substitute 2 into the g function. So g of 2 equals 5 over 2 lots of 2 minus 9. And that equals 5 over 4 minus 9. In other words, if we simplify that a bit, 5 over minus 5 is minus 1. Then, what we are having to do is doing f of minus 1. So we are subbing the minus 1 value into the function for f. So it's 4 take away 3 minus 1 squared in brackets, like so. And what we do is get the value of 1. So g, or f of g2, would equal 1. Alright, what does it ask us to do next? It asks us to have a look at asks us to find the inverse for g minus 1, which is the inverse of g. So 5 over 2x minus 9. So you have 5 over 2x minus 9 is the original g function. So y equals 5 over 2x minus 9. What we will do is, it depends on how you've been taught to do this, but you swap the x and y. So the first things first is you swap the x and y, because for an inverse the input becomes the output and the output becomes the input. Okay, so you swap the x and y, and then make y the subject. Okay, right, so what we would do here is you write y and then change it to an x, and then put 5 over 2y minus 9. Right, then what we do is we make y the subject, because we're trying to find a function for y equals. So you multiply, you cross multiply. If you want to imagine x over 1, you can do, but you get 2xy minus 9x equals 5 times 1, which is 5. Then it might be difficult to look at this and think, how would you get y equals? But if there's more than one y term, you factorise the y out and then divide by the bracket. But this one, there's only one term involving y, so you write 2xy equals 5 add 9x. And then you do y equals 5 add 9x over 2x. I'd first check if it can be simplified in any way. 5 and 9 over 2, no, those numbers don't simplify. So you could write it like that, or another acceptable answer would be 5 over 2x plus 9 over 2. That's also acceptable. Just let's double check if it asks for any particular form it wants it in. No, it just says find g to the minus 1. But remember, this is slightly different from GCSE, where you have to go an extra step further for A level. What you need to be aware of is writing the domain, in other words, the x values, okay, for a function, because a function doesn't include the expression for the equation for the function. It also gives the domain values. So it's talking about gx, you can sub in any x value not equal to 9 over 2. If you think about the domain and the range are the output values of g. And this is where I would always, you can use your graphical calculators, but I would think about drawing g of x. Okay. Now, how do you draw g of x? Okay, it is 5 over 2x minus 9, like that. Right, go to the base. This is a basic reciprocal graph, 1 over x. That would be the 1 over x graph. When you then do 5 over x, it will be stretched a bit further. 5 over x makes it a bit steeper, like that, but that's 5 over x. But what happens when you change the, you always do it when you're doing your graph transformations in the opposite direction, okay, to what it states for x. So even though it looks like you've times x by 2 and minus 9, you actually have to do it in reverse order. So you have to add 9 to the x coordinates. So what it would do is you move this graph 9 times, or 9 units to the right. So now it would have an asymptote at x equals 9. But then this graph would now be 5 over x minus 9. And then the final graph, this is what g would look like, would be when you change the x to 2x, as we know, that shrinks or squashes it in from the left and right, so it halves the x coordinates. So the asymptote now would be x equals 4.5. And you have that type of graph. The reason why it's important to know what the graphs look like is for when you're really doing the domains and ranges. Okay. As we can see, they take the domain of all values for g. Okay. So it's all values, x's and the reals, and that's why they say x cannot equal 4.5. Okay, or 9 over 2 as they've specified in the question. But what you need to think about is the range, okay, which is the y values. Now looking at this graph, the y values can be any, okay, any real number, apart from, if you notice, we have an asymptote of the x-axis. So y cannot equal 0. So the range, if you like, of this function, doing a bit of functions knowledge from A level, is y is in the reals and y not equal to 0. And the nice thing about when you're doing inverses is the range and domain just swap over. So if you've got the domain of the original function, it produces a range of that function, and that's the domain of the inverse function. So this is gx so that's the range for gx, okay, any y value not equal to 0. So if you're finding the domain of g minus 1x, even though it's the same values as the range of the original function g, what you have is the domain of g to the minus 1x is x is in the reals, x not equal to 0. Because it's the same specific values, you just swap the x and y. Okay, so y was in the reals, so you put x is in the reals. Y not equal to 0, so x is not equal to 0. If you like, they're the output values of g, so they are the input values of g to the minus 1, the inverse function. Right, you do that more in second year at A level, so I won't worry about it too much at this time. But when you're specifying your function for g, always put a domain with it. X is in the reals, okay, when we're specifying the function for the domain for the inverse. Okay, right, so when you're writing g to the minus 1x here, when you rearranged it, you could write 5 plus 9x over 2x, but you'd also specify the domain, which is a crucial part. X is in the reals, x not equal to 0. And you can sort of guess that from the denominator here being 2x. You can't have a denominator equal 0, so 2x cannot equal 0, so x can't equal 0. So that's what you have to do for your function. You have to write the domain as well. Right, so the next question on this particular part is to find the composition gf of x, giving your answer as a simplified fraction. So what we do here is you have to apply f, the function on the right hand side, first. So you sub f into g. So let's do that now. So what we're going to do is do the original function f, 4 minus 3x squared. So fx equals 4 minus 3x squared, like that. And gx is 5 over 2x minus 9. Equals 5 over 2x minus 9. What we would do is sub your f into g. So to find g of fx, what we would do is first of all put g and then in brackets, well, fx is 4 minus 3x squared, like so. And then you're applying g to that function. So you're subbing 4 minus 3x squared into the function of g. So wherever there's an x in g, you replace it with 4 minus 3x squared. like so. Remember, you always apply the right-hand side function first. Right, if we simplify this function slightly, you get 5 over 8 minus 6x squared minus 9, and you get 5 over minus 1 minus 6x squared. Right, it's up to you if you want to write it like that or times the top and bottom by negative. Okay, so you can write it as minus 5 over 1 plus 6x squared. And that would be the function. But remember, the domain of this function, because you were subbing it into f first, you have to specify the domain for f. And that was just simply x was in the real numbers. So x being in the real numbers here, and you would put x is in the real numbers here. That would be g of fx. Remember your domain when you're writing functions. Right, now it asks us to deduce the range of gfx. So what we will do is we can look at the function as a whole, but if you're subbing in the entirety of the real numbers into f, let's just consider, you can do it as a whole function, or what I would suggest is just look at the graph y equals 1 plus 6x squared, do it in chunks. What does the 1 plus 6x squared graph look like? Well, it's just the x squared graph times by 6 and then adding 1. So you're moving it 1 up if you know your graph transformations. So it's the 6x squared graph, but then added 1 to it. Now, if we are choosing all the real numbers to sub in, we get the entirety of that graph. But what do we notice? Because it's got a turning point at 0, 1, it's already in completed square form. So the 1 is the y coordinate of the turning point. There's no x in the bracket that's squared, so x is 0, the turning point. You do not have all the y values as the range. So actually, y, being the range, would have to be greater or equal to 1. But that's just for the 1 plus 6x squared. So in other words, 1 plus 6x squared for all real numbers is being between, or you could put above or equal to 1, but it's less than infinity. Okay. So what you need to do is put this on the denominator of this function. So, how would you make minus 5 over 1 plus 6x squared as large as possible? Well, from your balance knowledge in GCSE, because it's a negative, you need to make the fraction here as small as possible. So you need to reduce. And then how do you make a fraction as small as possible? You make the denominator as large as possible. So as 1 plus 6x squared tends towards infinity, 1 plus 6x squared tends to infinity, we know that 5 over 1 plus 6x squared, if you have a very large number on the denominator, then the fraction becomes 0. Because you're dealing with infinity, it can never exactly equal 0 because you can't sub infinity in. So that's why it will be a maximum of 0. You do the same thing for how you create a lower bound on this function. you can do minus 5 over 1 plus 6x squared. How would you make it as small as possible? How would you reduce it? Well, you have to make the thing in front of the negative sign. You want to subtract, okay, the largest value. And if you're going to do that, the denominator has to be smaller than usual. So you have to make the denominator smaller. So 1 plus 6x squared, it can equal as small as possible value of 1. So you put 1 in. So 1 would be the denominator, minus 5 would be the numerator. Right, so that means the value of the function, the range if you like, would be greater than minus 5 and less than 0. Just check the bounds. It cannot touch 0 exactly, but it can be equal to minus 5 because you sub the denominator as equal to 1 in, which is possible from the 1 plus 6x squared. So you have to include the minus 5. So that's why you would put g of fx being between 0 and minus 5, but remember you would have to include the minus 5 to get the mark. Right, and that's how you create the values. It's bounded between minus 5 and 0, the result. That is a bit tricky, but you deal with those type of questions more in year 13. Right, so the final part of this exam question was we've been given a quadratic function, 2x squared minus 6x plus k, and you've been told we need to find the range of values for where this equation has no real solutions. So you can think about this as a simultaneous where hx meets 3x because they've asked you to set it equal to one another. Or you can design that equation yourself by putting the function for f, which is 4 minus 3x squared, and put that equal to hx, which is 2x squared minus 6x plus k. Right, so what we will do to solve this is we will first make it equal to 0. So you've got 0 equals, because it's a quadratic you have to solve, 2x squared plus your 3x squared. Then you've got minus 6x plus k, and then your minus 4. Simplifying this equation now makes 0 equals 5x squared minus 6x plus k minus 4. Now what I like to do is like to put brackets around the coefficients. So the constant term is k minus 4, the b is the minus 6, and the a is the 5. Now you wouldn't be able to go any further at this point because you don't know the value of k. But we know this quadratic has no real solutions. So that's telling you that the discriminant, in other words, this quadratic will not hit the x-axis anywhere. So the discriminant will have to be less than 0 for that to happen. So b squared minus 4ac is less than 0. And then you sub in your values. Minus 6 times minus 6 is 36. Minus 4 times a, which is 5, times c, which is k minus 4. And this is less than 0. Multiplying out, 36 minus 20 times k minus 4. And then 36 minus 20k plus 80 is less than 0. collect the like terms, which would be 116 minus 20k is less than 0. 116 is less than 20k when you move that to the other side. Luckily, we've not got a quadratic in k here, so you don't have to solve that. And find the set of values, may it be the left and right hand side or the in between two values. We just have k is greater than 116 over 20, and simplify that by halving both or dividing both by 4. You get k is greater than 29 over 5. Just double check if it specifies anything about write it in set notation form or anything along those lines. Okay. No, it doesn't. It just says find the range of values for k, so you do not have to write it in set notation form. There's a bit of a tip if you needed to. The reason how I would usually write it in set notation form is something along the lines of, you would write the curly brackets meaning the set containing, you would put k is in the real numbers because it's any real numbers, not just the integers, and then you'd put the colons saying such that, and then you'd put k being greater than 29 over 5. That's in set notation. If you required it, but you don't for this question, so I'll just leave it as the first thing I've circled. That brings us to the end of those exam questions. If you want to see any extra videos or any type of other topics you'd like me to go through, then please let me know. And these will be available on the members area of my website. Any other questions you'd like me to go through, or any homework questions or revision questions or any questions you have from classwork, I'll go through them in my live office hours streams later this week and over the next few weeks. So I hope to see you there. Remember to keep on working hard and you will be rewarded. I'm happy to help, so I hope to see you in my live streams.